Perform the indicated operation, then use a calculator to check your work. So in our example here, we have a subtraction problem, and not only do we have a subtraction problem, but we have a subtraction problem where the denominators are not the same. So we know any time we add or subtract fractions, we need to be sure that we're looking for the LCD, the least common denominator. So let's think about our two denominators, 8 and 6. So if I've got the denominators 8 and 6, the hope is that we can just kind of access our mental multiplication chart to do this work, but I'm going to kind of write out what we should be thinking about. What we want to be thinking about are the multiples of these numbers, not the factors, not what goes into them, but what they will go into. So think about multiplying these numbers out. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. And notice we could keep going and going and going, but I'm going to just stop there for now. And then when we think about the multiples of 6, doing it the same way, 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, 6 times 4 is 24, 6 times 5 is 30. And again, I could keep going on and on and on, but I've gone actually even a little bit too far. We're looking for a common multiple, a multiple that shows up in both of these lists, and in fact we're looking for the least common multiple, and we can see that that least common multiple here is 24, and so that least common multiple of the denominators is the LCD. So my LCD is going to be 24. So we're going to have to change both of these denominators to a 24, but when I change the denominator, the numerator is going to change as well. Let's rewrite this problem and just give ourselves a little bit of space. Minus 1/6. And we said we want to get these denominators to become a 24 denominator, so I'm going to write that 24 down here. There's that minus sign, and here's the 24 here. So I'm trying to figure out how do I change 7/8 so that it will be a fraction that has a 24 denominator. Well, we want to be thinking in terms of multiplying, and we're going to focus on the denominator first. 8 times what is 24? Well, we know 8 times 3 is 24. But if the denominator gets multiplied by 3, the numerator also has to get multiplied by 3, because notice what I'm doing here. I'm just multiplying this thing by a giant form of 1. And 1 times anything doesn't change the value. So 8 times 3 we know is 24, so 7 times 3 is 21. That's my new numerator. Going to do the same thing over for my 1/6. I need to get it to have a 24 denominator. So 6 times what is 24? Well, 6 times 4 is 24. And if I do that to the denominator, I need to do it to the numerator as well. 1 times 4 is 4. Now 21 over 24 is the same fractions, equivalent to the fraction 7/8. 4 24ths is equivalent to the fraction 1/6, but now I have the common denominator, and now I can go ahead and do the subtraction. I couldn't do it while the denominators were different, but now that the denominators are the same, I know my answer is going to have a denominator of 24, because once the denominator is the same, it stays the same. And then remember, we just do the subtraction to the numerators. 21 minus 4 is going to give me 17. I want to stop and just check and say, will this fraction simplify? Because often it will. But when I look at 17 and 24, they don't have any common factors. So I know that's going to be my final answer. Let's double check our work on our calculator. If we pull the calculator up here, remember what we were doing. We did 7/8, so 7 fraction key 8. From that we subtracted, here's our subtraction sign, 1/6, so 1 fraction key 6. And when we press enter, there's the 17/24. The calculator's done all of the common denominator work for us and come up with the same thing we came up with by hand.